Okay, so if you know that how to do it, then so this is also one of the solution, right? This is also one of the solution which will give you what you want, which will have like two integrators and few resistances like this. This is like it has been kept such a way that they need less number of op amps, right? So here what we have designed, you need almost like 1 2 3 4 5 op amps. So this is the optimized design, but let's assume that this is not course on how to make optimized op amp. That is also different theory. So let's assume that this is the optimized one, but it has three op amps. We don't like this three op amps. Three op amps are not good because everywhere this triangle, we have to look at its frequency response, because this op amp will also have transfer function look like this one. It this op amp might be second order, third order, and the poles and zeros of this op amp will disturb the uh, whole transfer function. So we don't like more op amps. It has to be minimum number of op amps if we can do it. So there is one guy called, like two more guys came, Toy and Thomas. They realized that I'm going to give you optimized version of the whole backward filter, but instead of inverting amplifier, I'm going to do something else here. And for that, one needs to understand one theory. This is different theory which is not taught to you. Have you ever seen like there are do you know following things? Do you understand what is one phase, two phase, three phase system? What is three phase? Let's say starting with difficult thing. Yeah. So 120-degree apart, there are three different inputs with respect to neutral, right? And 120-degree. I'm not going into detail why we are doing this, but this there are some advantage in high power electronics. That's why we are doing. But in other way around, if I'm making two phase, what is going to happen? There are two inputs, one is plus and one is minus. It may not be it should not be 90. It has to be, look, total is 360-degree, right? So you divide it with 3 and you got 120, so it has to be 180-degree phase shifted. I'm telling you. I'm telling you the fact. I don't know. I need to talk to Gopi. 90-degree will definitely give some problem. So one side you are giving sine wave, one side you are giving some different, right? Plus 90-degree. Then the whole theory won't work ever. This whole circuit theory will collapse if we are doing 90-degree. I'll tell you why. Okay. So because of, he told 90 or 180. Then it's that's a different theory. I'm making just two phase. Why I'm doing all this thing? I'm not transforming anything. I want two phase system. Two phase system are the one where 180-degree. If it is something else, it's known as polyphase circuit. We are not doing polyphase circuit. So if it is two phase circuit where there are two inputs, 180-degree. So there is one small theory I would like to teach, which is not part of your course right now, but that is very important. What is generally happening, as I told you, if you don't understand, please let me know. I'll stop myself there. So if sine wave is your input, just few days back we learned that in frequency domain you are going to see only one impulse at omega, and similar minus omega will also have. Is there anybody who is learning communication? Yeah. No. Okay. So what is happening in other places? other than omega frequency, what is happening? You are expecting 0, but in reality you are not going to see 0, but you are going to see something else. And as this is in decibel, which is 20 log of the value, means you are not going to see on y-axis 0. 0 corresponds to 1, right, in logarithmic scale. So here there might be at some point you are going to see some extra harmonics which are actually not there, but this is because of this is a limitation of our instrument. So that instrument name is spectrum analyzer, which does this. So, but this is pure sine wave. But if my sine wave is passing from a circuit which is, let's say, diode circuit, RLC, what is going to happen at the output, in your opinion? What do you think, Komal? Are you getting my question or not? So if you have function generator sine omega t, that's the input. In this box, it might be diode circuit, resistor, inductor, capacitor. I'm writing this because all these are going to form some non-linear behavior. If it is linear, then output has to be equal to mx, where x is equal to sine omega t. This is y. Let's rename this. Yes. But if this is non-linear, what is going to happen? Now you are following my question. Do you want to use some series or something? You can use it. No problem. So how to solve such non-linear thing? Taylor series, right? So in reality, you are going to see this as well as something like this, where all these slopes are actually derivative of each other, right? This is what our Taylor series says, right? So you can see here, when I'm replacing x square with sine omega t, it's sine square omega t. But if I solve all those things, I'm going to get a function which will have sine omega t, sine 2 omega t, sine 3 omega t, 4 omega t, all omega t, right? This is what you are going to see when you are going to solve such equations, right? In school time, you must have replaced this with sine 2 omega t, cos 2 omega t, right? So you do that, then you will get all these things. Means y, which is drawn here, when it was linear, it was like this. But when it is passing through a non-linear circuit, you are going to see some more impulses which are coming exactly at 2 omega, 3 omega, 4 omega, and so on. Are you following this till now? This was the theory given by Leonardo da Vinci, right? He told that every harmonics, like, it will be reflected back, right? Omega, 2 omega, 3 omega, 4 omega. Yes, in school time you studied this one. I just made it graphical. All these things are known as noise, and this is known as signal. We like only signal, we don't like noise. This is one thing, right? So what I'm suggesting you to do, because all the circuits whichever we have studied till now, we made it with the approximation that it's a linear, but it's not linear. You can see that V out as a function of some s square is definitely, you can see that it's non-linear, second order system, right? You might have seventh order, eighth order, but still you are writing all linear equations. But that's not the truth. right now you are studying only here, but in reality there are noise is also available. So what I am proposing, let's have this non-linear circuit exactly, do control C and control V, keep it here exactly same. If it has one input, let's keep one input, one output, one output. If this input is X, we are not going to call this one as X, but we are going to call it minus X. And let's call this one as Y and this one as minus Y. When we are doing this, by the way, we are making this two-phase circuit, by the way. Minus X is going to give you exactly 180-degree phase shift, right? If this is sin omega t plus 180 is going to give you minus sin omega t, right? When we are doing this, what is happening? Y equal to mx plus m1 x square plus m2 x cube and some c minus y side. This is something like minus mx m1 x square m2 x cube. So all odd positions will have minus sign. When I am saying that there is one separate class of amplifier, earlier whatever you have studied in IC 161 or whatever we have studied, it is known as single ended amplifier or single ended circuit, which has one input, one output. But if you create such circuit which is kept on top, this is known as differential circuit or differential two-phase circuit, which has two inputs, two outputs, and I'm going to take every time difference. I'm giving input as actually 2x and checking the output as 2y, because y minus minus y will give you 2y, x minus minus x will give you 2x. When you are doing this, what is going to happen? 2y is equal to 2mx plus 0x square plus 2m2x cube plus 0 times x raised to 4, and I have written something called C, right? C is the entry. This is a constant value, will make sure that your transistor will be in saturation or in active mode, because you need some voltage here, right? So there are two things, one is sine and one is DC potential. So that DC potential when I am giving here, that also DC potential goes to 0. The name of this DC potential, we were calling it common mode voltage, and all these even entries we were calling as even harmonics. So we can say that when you are applying some circuit which is differential two-phase circuit, you are going to see zero common mode voltage and zero even harmonics. Yes. So ultimately your noise contribution get reduced in average. This is what we want. If you can do even remove this one also, it will be like great, but we don't have such theory right now, right? So if you can develop it, it's like $1,000,000 question. Right? Even in communication everybody wants such thing, right? So that's why we want that. So now what Toy and Thomas is saying, if entire world is differential, we are not going to have one input and one output. We are going to have two inputs and two outputs. That's the normal thing. You cannot have every time single ended thing. You will have always one plus and one minus, and both are 180-degree phase shifted. This is the reality. So what he is saying, if I have such circuit and I can copy the whole thing, here the output has to be, so if this y is here, y output, that is equal to minus x, right? X is output, so it's minus x. So if I draw same circuit other side, because it's differential, so other side y is equal to x, other side, because this side v in will be minus v in. So I can short both of them as follows. So here it was y, which was x, sorry, minus x, and y plus x. So I can take minus and plus, which is available inherently. I don't need extra op amp. This was told by Toe and Thomas, and told that effective number of op amps which I need will be 2 only, not 4. So that was the thing. Are you following, or too much heavy theory? I don't know. I'm asking you. Huh? So this is generally in differential amplifier. In analog, if you are studying analog sometimes, then you will study this in detail. But to remove even harmonics and common mode voltage, maybe like 741 also. So the so-called course called analog, that is only about how to make op amp. This triangle, what is inside this triangle, that theory is all about analog, right? One more time I can advertise. If you wish to learn it, it's next semester. Same teacher, same way, same surprise quizzes. Right. Do not afraid with the course called 512. It is a MTech core course, but most of the time my BTechs are getting higher grades than MTechs. Right? You can talk to maybe Himanshu. Himanshu also got good grade. He got almost over A, right? Yeah. So all my BTechs are generally getting, like, they are toppers of E512 most of the time. Okay. Hmm? 512, E512. Huh? Yeah, output of this op amp. Is this what? That, huh? Where is the output? Okay. We take the difference of these two. Okay. One more thing, you can see here extra resistance here. So just for completeness, do you know the difference between tank circuit and lossy tank circuit? Is it same? Do you know the difference between these two? So what is that? Hmm? Yeah. You are saying something. What's your name? Huh? Okay. So what is the difference between these two circuits? One is ideal, okay. Inductor and capacitor, let's say. Okay. This is a tank. Okay. So you want to add parasitics of like inductor and capacitor, that you are going to call it lossy tank. So similar to that, if you have an integrator, this is very difficult to make such integrator. It can be made only on paper. It's not possible to make these this kind of integrator is known as ideal integrator. But in reality, this will be the case, and we are going to call this integrator as lossy integrator. Okay, because it creates loss from resistance. Of course, capacitor has to charge, but if there is a resistance in parallel, it will pull out all the charges, right? So it's a bad thing. So we don't want such thing, but still it is there. You cannot avoid it. This is a parasitic, and Toe and Thomas has drawn parasitic resistance. These are not real resistances, right? So still we have something like 10 minutes. We can talk. Are you following this till now? Okay. Okay. If you like to do some like exercise on op amp, let's do that. Okay. There is one question I'll ask you. So all the people who are making the chip, they don't like inductor. What do you think? What could be the reason? Area is very high, right? And of course, the problem with analog circuit designers are they are not very good at electromagnetic theory. They don't want to follow electromagnetic theory. It's one of the difficult course. What you are studying, maybe Gopi is teaching. So that's one of the difficult thing. One has to analyze lots of magnetic theory associated with inductor. So if you don't use inductor, then life is very simple. So to avoid that, so there is one technique given by same uh, bikeweed guys, Toy Thomas. They told I will realize inductor using some different impedances. Those impedance might be combination of capacitor resistor, but you can make the inductor here. This is, by the way, if you are looking into this Zin, you are going to see the combination of impedances, and that will give you inductor or something like you can see some s times some this value, and through that you can tune it. But this is using op amp, so that's why we are going to call this is simulated of inductor. This is not real inductor, but if you're looking into the circuit, you are going to see effective inductor somewhere. So now you have to solve that. You have to solve this with considering this is ideal op amp, and that will be the last thing. I wanted to teach Butterworth approximation, but it's difficult. I don't know. Right? So we'll avoid that. You can learn that in future course DSP. If in case somebody is interested in DSP as well as analog, please let me either you let me know, or you can talk to Anil Sahu. Right? Anil Sahu may be teaching DSP, and I am teaching analog. So if you are interested in taking both the course, then we will keep slots different. Generally, every time both the courses are coming in same slot. Huh? Himanshu, is it correct, right? Or you can take this course in fourth year if you have enough N2. I have seen most of the people who have N2 in third year, but they don't have N2 in fourth year. So assume same thing. It's a lossy network, right? There has to be some resistance. Right? So you will learn only one course. You can go only in one side. So by the way, what will be the value of V1, V3 and V5? V1 is Vx. So what is V3? Hmm? V3 has to be Vx, right? In ideal case, V plus equal to V minus, and there is no current flowing inside. Right? So in from all the branches, what is the current flowing through all branches? You have to go to the last point. So Vx divided by Z5, that's the current flowing through this one, right? Similarly, you can find out V4. So V4 and V2 are unknown, and I want to find out Vx by Ix. If I know what is the Ix, Vx by Ix will give me the Zin. So you try. So V4 is equal to V5 plus Z4 times I. Let's call this one as I4. What is I4, by the way? How much is I4? So this current cannot go inside. So both the side current will be same, and how much it is? Vx by Z5. Now move further and find out. Reach till here. Use KCL, KVL and find out. Right? Solution is already given in book, but you try. So I'll definitely ask one question on op-amp solving thing, right? So filter will be some circuit which you have to solve. Whose transfer function or maybe input impedance. We have solved 3-4 circuits. Maybe I can give you even some equation, and that equation you have to realize. Right? Similarly, you can find out current from here, or maybe from here or from here. So from whichever way you want to start, you can do that. So there are many ways to solve this, right? So before you leave, even Ncan, please can you write down some small feedback on the course? I'll definitely use it for my next time course. For your juniors, I can improve. If you think there was some mistake, some problem, right? I'll try to improve. Once you are solving in your head. Node at 4, yeah. So V4 is equal to V5 plus the current flowing through that. Mm-hmm. Okay. That's the current equation. So that is also correct. Yeah. V4 equal to Vx. No, no. That's not possible. Then there is no, 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 no. It's not going. Hmm? No, 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 no. The op-amp is not contributing any current.
वोल्टेज कंट्रोल करंट सोर्स कैसे बोलते हैं?
Voltage control current source. This is voltage control voltage source. Op-amp is voltage control voltage source.